Hi everyone! I thought we would spend a few minutes talking about radians and degrees. Well, what is a radian? A radian is a different type of measure than a degree. It is a ratio of an arc length to the radius of a circle. Let's draw a picture. Okay, suppose we have a circle where our radius is 1. We call that a unit circle. And if we were going to go around and draw angles in this unit circle, we start over at the initial side. That's going to be our positive x-axis. And then we will go around counterclockwise measuring our angles. We know about angles in degrees. There's 360 degrees in a circle. So if I started here and I went a quarter away around the circle, we would be at 90 degrees, halfway around, 180, 3/4 of the way around, 270, and I could make a complete circle and be back at 360 degrees. Okay. But a radian is a ratio of an arc length to the radius of the circle. Now let's think about what we know about circles. Circumference is equal to 2 pi r. Okay, and if our radius is 1, let's go ahead and solve for r. But we know that there's 360 degrees in a circle. So our circumference is 360 degrees is equal to 2 pi r. Dividing by 2 pi, 360 divided by 2 pi, let's just reduce 360 divided by 2, and we'll call that 180 over pi. And in our case, our radius is going to be equal to 1. So 180 over pi is equal to 1, which also means that pi over 180 is equal to 1. Okay, so keeping that in mind, if our circumference is equal to 2 pi and it's also equal to 360 degrees, take the 2 pi and we're going to divide that into 4 parts. 2 pi divided by 4 would be pi over 2. 2 pi divided by 2 pi. So we have 1/2 pi, pi, 3/2 pi, and all the way back around here to 2 pi. So there's not nearly as many radians in a circle as there are degrees. Pi is 3.14, so 2 pi is 6.28. There's only 6.28 radians in an entire circle. Okay, what I want us to learn how to do today is to convert radians to degrees and degrees to radians. So let's start out and convert degrees to radians. Suppose we have 100 degrees and we want to make that into radians. We want our degrees to cancel out, so I'm going to multiply by either pi over 180 or 180 over pi, depending on if I want my degrees to cancel out. I have degrees here, so I'm going to put the degrees on the bottom and pi radians on the top, so we can just multiply straight across. 100 times pi divided by 180, and we can even reduce that. 20 goes into 100 5 times, 20 goes into 180 9 times, so that would give us 5 pi over 9 radians. You could also do that as a decimal. 5 times pi divided by 180. .087 radians. Okay, so we can do that either way. I want y'all to try this one. $150 and decide what you want to multiply by. Pi over 180 or 180 over pi. Again, degrees go on the bottom, radians go on the top, and you'll notice I wrote this two different ways. One time I wrote it as a fraction, and the next time I wrote it as like a unit conversion, the way that you would see it in chemistry. Either one's okay, it's just another way of multiplying fractions. 150 times pi over 180. 150 and 180 are both divisible by 30. 30 goes into 150 5 times. 30 goes into 186 times. So that would give us 5 pi over 6, or you could change that to a decimal. .62 radians. Let's go in the other direction. Radians 2 degrees. And I have 3 pi over 4 radians. And I want the radians to cancel out and be left with degrees. So I would multiply with degrees on the top and radians on the bottom. And then let's see what we end up with. Your pi's cancel. 3 times 180 divided by 4 would be 135 degrees. And you can also write this as a unit conversion. Just depends on how you like to write your fractions. Either one's okay. It also works for negative angles. If we have negative 7 pi over 3, convert that to degrees. Radians on the bottom, degrees on the top. 3 goes into 180 60 times. 60 times 7 is negative 420, and our pi's canceled. So negative 7 pi over 3 is the same as negative 420 degrees. Okay, we will have a different lesson on reference angles and coterminal angles, but now we know how to convert back and forth between degrees and radians.